All right, so we're going to talk about Trojan the Progressive app. I'm not going to do it live. I have enough trouble with my live demos for the moment. This will be the last Android set of demos today. I think we've good enough through this. But the point is here you need a Debian Linux guest to unpack the app and rebuild it, and an Android emulator to run and test the app on. So you install Android Tools, ADB. That gives you Android Debug Bridge on Linux. And then you install this tool, APK tool, which is a reverse engineering tool that will unpack Android apps and let you modify them and repackage them to make modified apps. So once you've done that, um, you can download an Android app, and this is the Progressive app from a couple of years ago. I have no reason to think it's more secure now, but they change it so the specific commands are different. And then you disassemble it with APK tool D and minus F minus R or switches to not bother unpacking the incidental stuff like the images. And that will unpack the app into a big tree structured directory with many, many files containing Smalley code. So it might seem like it would be very difficult to find things, but you can notice that this is not obfuscated in any way. You can just read the names of all the folders, and you can also read the contents inside there. So you can just do a grep recursively to look for the word login and the word password on the same line. And there aren't very many lines, only about 10 or 15 lines like that. And you can see that there's really only a few files, and one of the files is this one called loginviewmodel.smalley. So you can just edit that file. I use Nano because I'm kind of a wimp. The more professional people like VI. And then you just search through here and you will find a method that performs a private login online account here. Now, here's how you can learn how Smalley works. Smalley is the code that runs in a Java virtual machine on an Android device, and it works with local variables, of which there can be a total of 16. So this app right now has 5 local variables which it uses. So I want to modify this app to steal the passwords. So to do that, I need another local variable. So just change that locals to local 6. Or you can have up to 15. So I can make a new variable. If you try changing one of the existing variables, you're likely to make the app crash. And one thing when reverse engineering and modifying code at this level is you have to be very careful. It's very easy to break the app and make it crash. So it took me some practice to learn how to do it. And I learned to only make 1 or 2 changes and then recompile the app and run it to see if it crashes. This is the lore of reverse engineering. So make it local 6. And now you can use a variable called v5 because they start counting at 0. So the v5 is the new variable that wasn't there before, which is therefore available for my use. And now I can just execute these Smalley commands. This is going to put a string Trojan stealing progressive credentials in v5, and this is going to put it in the log. That's how you log it. And I'm going to log this text message, and I'm going to log the values of variable 2 and variable 3, which are the registers. And the reason is because you can see it down here. Here's where it moves the resulting object to v2, and what it puts in there is the password. And here is where it makes this is where it puts username into v2, and this is where it puts the password into v3. That's what these lines do. These lines are not very much more complicated than just Java code. You see they have useful names like username and password. So v2 is the username and v3 is the password, and this Trojan will put them in the log. So now you rebuild the app with APK tool B. Now Android apps have to be signed, but the signature is never verified. You can self-sign them. The only purpose of the signature is that if you install an app from a trusted source like the Google Store, if you trust it, which you could argue you shouldn't, then when you have an update for the app, it has to have the same signature. So you can't put out a fake third-party update and fool people. If you want to fool people into putting in a poisoned app like this, you would have to reach people who don't already have it installed, or you'd have to convince people to uninstall the old version before installing yours, which is a fairly simple matter of social engineering. So you have to create a code signing certificate, a self-signed certificate, so you don't have to buy it anywhere. And then you sign the app with it with a tool called Jar Signer that comes with the Java development kit that we installed earlier. So you can now make a modified app that's signed and you can run it. Get it out of your Linux machine, put it on your Android emulator, and now when you run the modified app, you can just look in the log with ADB logcat, and you will see the name and password stolen and put in the log. And I did this to an awful lot of apps. Like I reported it to all those top 10 uh, banks, insurance companies, and stockbrokers. Most of them don't care, but this is a flaw in their app. Um, so that shows you the manual process of taking apart an app, reading the compiled Smalley code, modifying it at that level, and putting it back up. And it works. It's not too difficult, but it's fairly involved. But a much simpler way to do app analysis is with this tool called uh, JADX GUI. And this is a Java-based tool. And let me see if I've got a terminal open. I do. Okay, I'm done with this. I'm going to Control C this and exit and clear. All right, now I can just run JADX GUI. It's a Java app that runs directly on my Mac. And as you can see, it has a graphical user interface. And now you can analyze apps in there. So I'm going to put in this one. Now, this is the Indian identity app. There was a guy on Twitter, a researcher, who analyzed this thing. This is like the Indian, a virtual ID card that's used for all kinds of purposes by the Indian government. And a security engineer demonstrated that it had many flaws here. So I'm going to open it. It's in my downloads folder, and it's this one, Indian.government MAdHAR Plus. So there it is. And what this does is it reverses the app all the way down from the compiled APK to readable Java code. So you can just see the code here. Here's the code they wrote for it. Now, by the way, they used a ProGuard on this, which is a free tool from Google to try to protect your app by renaming some of the methods, just A, B, and C. So it removes some of the names of the folders and methods, but in practice, it leaves all the important ones alone. I can still find passwords, credit card numbers, and everything else without much trouble in it. So if you go into these folders, you'll eventually get down to the code, and there you see readable Java code over here. I wonder if I can make that bigger. Ah, good. There. So this is just Java. So you're reading Java source code created from it. All right, and so what you can do here is you can find the launcher activity. If you expand resources and go to the manifest is the main configuration file that controls the app. So I go to resources and then Android manifest. This is the Android manifest, which shows the permissions it has, like to reach the camera and the SMS messages and so on. And the launcher activity is the first thing that runs when the app launches. And I should be able to find that in here. I found it down there, an activity named launcher. And I might be able to spot it, and I might have to search for it. There is a search. Okay. It's searching in too much of the area. And I'm in the right file. Someplace in here is launcher. I mean, there it is. There's the launcher. So now it shows me what the category is, and therefore I know what activity is launched here. So it's this one called splash screen activity, which is what you might imagine. That is the path to the particular activity that launches when you first launch the app. All right. And so the official Android documentation explains this. You launch the activity, And the first thing it runs is the onCreate method of the first activity. So we can read the onCreate method by going to the Indian Gov um, here, and then the UI for user interface, and then activity. And now we can go to splash screen activity here. And here's the code that does the splash screen activity. Now, um, we want to look at the onCreate method. This is on post execute. This is do in background. And here's on connected, on create. So here's the on create activity, the first activity it runs. And what we're going to do is notice these sections. This if FA and FB then do something, that is going to turn out is the, I think that's the jailbreak detection. Let me read my instructions here. Those are the two methods, FA and FB. And the second one, that's app modification. Remember, I complained about the Progressive app and many other apps saying they don't protect you from code modification. There are ways to do it. This app has a defense against code modification. This is going to take a hash of the current app that's running and compare it to what it should be. And if the hash is wrong, it's going to reject the app and say you have to update your app before you can run it. And this other one down here, a method named B is going to be the one that decides if your phone is jailbroken and rooted, and it won't run on a rooted phone. The same defense Staples put in the app after I posted the vulnerability. So what we're going to do is we're going to find the integrity verification code and learn how to remove it. So that's going to be BF, UI activity BF. UI. Let me see if I can navigate my way there. Indian.gov. Okay. UI activity. I'm having trouble finding BF. Let's see how it looks. Oh, a splash screen. There. It's not the UI. Okay. It's up here. It's just B here. Okay. B and then F. All right. And here's some, collision with root package name. Okay. Now, all right. Navigate to that module. Here you can find the A method, which is right here. Okay. And what this does, we may be able to read it. This compares a SHA-256 hash. This A method compares a hash with the expected hash. Although I must not be in the right place. Indian Gov BFA. Indian Gov BOFA. Well, Indian Gov BFA, I may be just a little Indian Gov BF, and then you want the public static Boolean A, which I am having trouble finding. Here's B. Those are variables, not methods. A is a string. These are methods. A of string, okay. And here's A of string exception. There it is, I think. All right, anyway, I'm not going to struggle more finding it. The point is, you can see it here. This is where it calculates the SHA-256 and compares it. So you can remove that by modifying the app the same as the one we talked about before. On Linux, you take it apart, you go to the splash screen activity, and then you go in, here's the Smalley code that invokes that, FA and FB. And if the app is modified, it sets the parameter P1 to 0 down here. So all you have to do is make it so it always just sets P1 to 1. And then it'll run the test, and whether the test passes or fails, it will always just report that the test passed. That will turn off the integrity control, so it'll accept a modified app. The next thing is to disable root detection. And what this does, you can see in this code here, it calls a library called root beer, which is a code just to detect rooted phones. And what you can do is just comment out a few lines of code that do that test so it will not test and not crash when it's going to test. So those are the modifications, changing a 0 to a 1 and commenting out about 8 lines. That's all you have to do. Then you can rebuild the app, re-sign it, sign it, and now you can run the new app and see it go. Um, and so this applies, it's kind of a good demonstration of how you use the Java add that you get from JADX GUI to guide you, and then you can do the modification at the level of Smalley. And there are a couple more fun projects here. I got these from Mandiant. This one I got from Mandiant. Mandiant has a great capture the flag contest called the Flare On contest, and they write these fun games. So they wrote an Android app called Flare Bear, where you can feed, play with, and clean your bear. And this is, there was a thing called Neopets or ePets or something. It was like this people played with a while ago. And there's a particular pattern of these actions that will win and give you a flag. And to find it, all you have to do is take it apart with JADX GUI, and then you can read the methods. You can read the code here. So it's going to be ecstatic and show you the flag when you have a mass of 72, happy of 30, and clean of 0. These are the variables. These are the winning conditions. And now you can find out what feed, play, and clean do by examining them here, and you'll find, feed adds something to the mass, and play adds affects the mass. So you can figure out how these variables all start at 0, and you can just read the code to learn how these operations change them, and then find the pattern of clicks that will win. So you don't actually have to modify the game at all. You can just read the source code to learn how the game works and figure out how to win. So that's good fun. Just gives you practice at navigating your way through that decompiled Java code. And this one's even easier. I just put it in because it was important. About a year ago, there was a serious vulnerability reported in this product called Chirp that had a hard-coded password in it, which is a common flaw, and it turned out to be incredibly easy to find. There's news articles about it here. Yeah, this is Chirp Systems. This was a smart lock, had Chirp Systems, and it turned out there was a hard-coded password that would get you in everybody's house, that would open the lock without having the required code. So it's a pretty serious flaw, and it's incredibly easy. All you have to do is take it apart with JADX GUI, and you can find the password. Just search for the word password, and you'll find the beacon password just set in a configuration file here. So this is the kind of ridiculous, insecure problems you see in a lot of Android apps. And so that's what I wanted to show you about Smalley. I'm not going to go into the details of the app components, but I just want to mention this one here. If you want to get into what's called instrumenting, Frida is the tool you use for this, and this is a technique used a lot to analyze Android apps and iOS apps. What you do is you don't modify the app at all, you modify the underlying operating system, which sounds crazy, but that's how it is. You install this thing called Frida, you run it on the phone, and you run it on your machine on the outside, controlling it, and now you can affect the system calls, as we're going to talk about a lot as we go into malware analysis in the next bit here. All apps work by using the API of the operating system. If you want to draw a window, you ask the operating system, please draw a window. You ask the operating system, please read the keyboard, things like that. So you can capture those calls to the operating system and modify them. So the app continues to run, but it's now running in a modified environment that has unexpected results. And this is a common way to do security testing and hacking of apps. And that's what Frida does. So it's good to set up, and then you can, for example, here's an app that detects that it's in a rooted environment and won't run for that reason. And what you can do using Frida is you can create a payload that will run in JavaScript for some reason that will take the API calls that would have detected that and instead lie and tell them the phone is not rooted when it's really rooted. And you can do a lot of things like that with Frida. So this is the project where you can get that set up for Android. It's a little tricky. The one thing that's held me up many times learning to do this is Frida has many versions, and you have to be careful to have exactly the same version on the phone as you have on your host system to act as the server. And if you don't, nothing will work. That took me a long time to learn. Anyway, you can try that if you like. There's a little capture the flag kind of contest you run here, and you have to instrument the phone to solve these challenges. So that's an important skill. It is a little tricky to set up, though. Um, it's even harder to set up on iOS. All right. Well, that's all I wanted to show you about Android, I think. Let me stop this.